So we'll go ahead and get started here. I don't have this filled out for next week yet, but my presumption would be is, what did we do yesterday? I know what we did, but you tell me. What did we do yesterday? Okay, and right. But if we're going to do this in a lab setting, okay, that's what this is based off of, okay? So what we're seeing here is, for some of you that are possibly going to take this course in college, is that anybody? Because I ask that a lot, but sometimes that could very well change from, I wouldn't say week to week, but maybe
I
from...
think you almost have to take chemistry if you want to go definitely into nursing.
Not only that, but you'd have to take
Dental
the
and
organic and biochemistry class.
like general, like you most likely have to take chemistry.
Right, and I would like to think that, and you might know more about this than I do, students who have taken these courses in the past, whether it's the organic or the A&P or the biochem or the general chemistry, as far as I know, they're doing just fine. When I say there, I mean former students. Hopefully they're doing all right. So what we mean by this is, if you're taking this in college, maybe this is your turn to be, and I don't know if they'll say we need a group leader. Maybe there's 3 people in a group. Usually it's just 2. And sometimes if it's small enough of a class, you're going to be on your own, okay? But regardless, what we had done on Thursday was it just gave you 2 numbers, okay? Well, you could say, well, looks like that's what we're doing here. We only have 2 numbers. But this is probably a little more, let's say, content towards this, of what we'd be doing as an activity. The question is when that activity would take place. Monday, I think, is too early. Maybe Tuesday. We need to be able to see how comfortable we are with this. Wednesday, I think, would be out. So my best guess would either be Tuesday or Thursday, okay? And it would be something similar to this, but what's going to happen, okay, is we're going to give you a bottle, well, not a bottle, but we're just going to put a sample of an unknown powder into, like we said, this is an evaporating dish. A crucible is just a little bit smaller. It probably is about like this big, and it sits inside of a clay triangle, but the concept is still the same. You put your powder in here, because what do you have inside that powder besides this lithium chlorate? You have water that's locked up in that substance, okay? So what's your task then is to determine, like this bottle we could leave out because it just has an X in front of the H2O. So what would be the point of giving you the bottle that tells you how much is on there? Because
you know the answer.
you would know the answer. That's right. So what was I going to state with this? Oh, and then like I said, we'll put these in different powders, and then, or not different powders, different containers, and then try to experimentally come up with how many moles of water are in there, because not everyone's going to have the same one. And it probably won't be copper 2 sulfate because, and maybe we would. I think in the past we've done some either iron chloride or iron 3 chloride or iron 3 nitrate. We've done some magnesium sulfates and probably maybe some cobalts or some chromiums. I can't remember which for sure. But there will be a variety for you to pick from, or we'll just say here, you tell me how many moles of water are in this substance. So, and if I was sitting out where in your chair saying, why would we do this? Well, maybe we're just filling up the day for something to do and play with fire. Well, maybe. but there's probably something more extensive that that's more detail oriented than what I could explain. And when we're doing these empirical formulas, one of the things that, in case you're wondering this, and we're talking about this evaluation that you had done, why are we calculating this out if a machine does it? That's well, true. I mean, that's a really good question.
But the machine doesn't work.
Well, it wouldn't be that the machine doesn't work, but the approach I like to explain is what happens if you are a forensic scientist and you are sitting on the jury, and you are not on the jury. You're called as an expert witness, okay? Yes, you could say, okay, I work for the state of South Dakota as a forensic chemist or forensic scientist, something like that. And you have to explain some of the evidence that's going to be put on trial. To me, I think there's a little more to it than just saying, well, we took this unknown substance, we put it in a mass spectrometer, and said this is what the compound is. Okay? Maybe that's what would happen, maybe not. But what we want to have you know is a little deeper understanding on how and maybe why that mass spectrometer works the way it does. Because you can mathematically calculate that should you know all the data. Just like this, it's probably just more for problem-solving abilities, and that way you can take this content over in the lab and you can actually get raw data. Rather than looking at a book, looking online, you're actually doing the same type of problems, but you're doing it rather than reading it out of a book. And I think there's hopefully some value to that. So, and you're probably not going to come up with an exact mole ratio, because yesterday, didn't we come out right at 5?
Yeah.
The chances of you doing that are probably pretty slim. And it's not because you're a terrible, no, it's not me saying that, but you might be thinking, I'm a terrible chemistry student, or I can't do this right. No, that's not what we're getting at. I think it's more important to say, this is a high school chemistry lab. This is not Georgetown University, or this is not Iowa State University, or even SDSU. The chances of replicating this out to get a real whole number answer are really, really small, okay? Because that's just the way it is, because you're over in the lab and it's just not going to give you 100% results. This one probably will, but this is because this is an example that probably came out of a textbook. So with this lithium chlorate, we're saying it's your turn to be a group leader in your college lab on hydrates, okay? So this is about the time. I've done this in the past. So who can we pick on in here? So you can thank your lab partner. So you think, oh man, I want to be group leader because I want to impress this other guy. Yeah. Usually it's the other way around. Usually it's one of the guys want to be the group leader. And
Yeah, I like idiots.
Yeah, I don't
I like the big stupid